All right. Good afternoon, everyone, and welcome. My name is Kelly Rio. I'm the Executive Director of the Center for Operational Excellence here at OSU, or COE for short. Thanks for joining us today and kicking off our Lean into AI series. COE is really proud to host this series in partnership with leading lean nonprofits, Catalysis, Central Coast Lean, Eyes to See, GBMP, LEI, Shingo, Toyota Production Support System Center, and the University of Michigan. Together, these organizations form the unprecedented collaboration called the Future of People at Work. And we're really looking to prove that excellence multiplies when we unite. I want to begin by sharing more about our vision just quickly on this series and the intersection of lean and artificial intelligence. So if you're logged in today, I'm sure you're aware that AI is rapidly reshaping how organizations solve problems, make decisions, and deliver value. And at the same time, lean and continuous improvement principles remain the foundation for building that adaptability and high performing systems. And the goal of the Lean into AI series is to bring together leaders and practitioners from across the operational excellence community to explore where these two powerful forces meet and how they can evolve in tandem and provide synergies. Through real world examples and candid discussions, we hope you'll walk away with actionable ideas for integrating AI into your lean journey. And today we're joined by Purdue professor Ali Shakouri and Toyota's Jamie Bonini for a conversation on their work in lean and AI. And before I jump in, I want to remind you that you're invited to use the chat, reactions, and Q&A functions. Chat you can use to ask questions about technical challenges or share your experiences and reaction to the speakers today. You can chat with one another as attendees. And the COE team will be there to respond to any questions or issues you may have. If you have a question for our speakers regarding content, please post those to the Q&A feature. You can upvote the questions that other people post there as well. And lastly, we are recording this video or this session for future viewings by all. It'll be made available through YouTube for the public and then posted as usual on COE's digital content archive for COE members. All right, so I'd like to introduce Steve Pereira. He is our Lean into AI series MC who will guide us through today's conversation. Steve has spent over 2 decades improving the flow of work across organizations. He's worked through tech support, IT management, build and release engineering, and as a founding CTO for Enterprise SaaS. He serves as a lead consultant for Visible Value Stream Consulting, as a board advisor to the Value Stream Management Consortium, chair of the OASIS Value Stream Management Interoperability Technical Committee, and the co-founder of the Flow Collective to bring flow-focused professionals together. And since 2017, he's been developing and facilitating flow engineering to make flow improvement in large organizations accessible, collaborative, and actionable. Please welcome Steve Pereira.
Thank you very much, Kelly. I didn't realize my bio was such a mouthful. I gotta refine that for the next one. But thank you everyone for your patience. I'm gonna jump right in and introduce our guests for the session. First, we have Ali Shakouri, who's an electrical and computer engineering professor and associate dean of research and innovation at Purdue College of Engineering. Currently leads an NSF Future Manufacturing project with colleagues at Purdue, Harvard, and Tuskegee University, focused on deploying artificial intelligence techniques in small and medium manufacturers. And we have Jamie Bonini, who's the president of Toyota Production System Support Center, a not-for-profit corporation affiliated with Toyota Motor North America. In his role, he provides Toyota production system expertise to North American organizations, including nonprofits and businesses, with the goal of building high engagement, high performing cultures that improve quality, productivity, and reduce lead time. So let me just jump in, because what I'm reading in those bios and what you might be hearing in the audience is that you folks are really involved in implementation and actual hands-on transformations in organizations. Jamie, can you tell me a little bit more about that from your perspective? What does it look like to be hands-on in this field?
Sure. Thank you. And welcome, everybody. I'm really looking forward to the session today. And thank you, Ali, for joining us. Lee and I are work together on various projects, so looking forward to this. So let me start off with the group that I lead called the Toyota Production System Support Center is a nonprofit that has been sharing the Toyota production system culture outside Toyota for over 30 years and over almost 600 different applications. Half of those are with companies, half of those are with nonprofits like hospitals, vaccination sites, governments and like, and all kinds of small to mid-sized companies that are not automotive. So we live in the world of help building a TPS culture outside Toyota. And very briefly, I want to start off with what is the definition of the Toyota production system, because there's some common misconceptions about that this our overall community that Kelly talked about is trying to address. So here's our definition. The Toyota production system is an organization-wide culture of highly engaged people that are solving problems and innovating to drive performance. So highly engaged is like the Buckeye fans after a national championship. Passionate people, and what are they passionate about? Problem solving and innovation and driving performance. And it goes everywhere. Now that culture is created by a system of a philosophy that underlies some technical tools that are around just-in-time and flow and Jidoka, which is about signaling problems when they occur. And then there's a leadership role, which is to engage and develop and teach people to surface and solve problems. So that's how we talk about TPS. The broader lean community I'm very excited about has come up with an enhanced, broader definition that I'll share here, which is lean or continuous improvement is everyone learning how to create and flow value easier, better, faster, cheaper for everyone's benefit. That's a very broad definition that certainly overlaps with the Toyota definition of the Toyota production system. So that's what we do. We work outside, we work on-site at organizations. We help build this culture to drive performance in safety, quality, productivity, and engagement.
Awesome. I love getting definitions out of the way for clarity and to get everybody on the same page. So continuing from that, Ali, can you tell us from your perspective, what do you mean when you talk about AI and artificial intelligence?
Yeah, good afternoon, everybody. It's a pleasure to participate. AI is one of the buzzword, and sometimes the spectrum of what described from digitization to IoT to AI, we mix everything. Let's kind of go with the history. All of us know that computers and data change a lot of processes and started from 1960s. That's the first, I call it digitization. Then in 90s and 2000, the internet came in, Internet of Things. That's the second way. You have easier way to get information. But often the way decision was made was based on some analytic processes or some sort of human decisions. What really have changed since 2010s, in the last 10, 12 years, is ability of machine learning to do prediction and decisions at the scale that was not possible. And what is interesting is that the technology or the fundamentals were around for 40 years. But with just new computing power, we could do certain natural language processing, image processing that we could never do before. And that has really changed quite a bit. So that's one element is the prediction using data, using learning by example, which is not analytical thinking, is a different way of thinking. People call it black box and so on. So that's one. And the latest kind of incarnation of that is what generative AI is, and the chat GPT and all of that, which from my point of view is an easier way to access lots of information. Before you do Google search and you had to mentally bring it together, make a summary. Now you have machines, they can do that very good. And that is also the question is how this can change organization, that how this can change future of work. I think two elements of AI, the predictive power as well as some of the generative part are something we want to discuss.
Beautiful, beautiful. So stepping back a little bit, now that we've got some clarity on those terms, let's combine them together and talk about, the overlap and the confluence of these things. So Jamie, what does a typical Toyota production system transformation effort look like? And then from your perspective, what does AI add into that effort that enhances it? Or, I think what's really interesting is how does it change?
Yeah. Great. So Ali and I have visited some companies together, which has been a great pleasure on my part. He's visited some of the Toyota factories, and we are working very hard to find a company or several companies that he and I can work with together so we can actually realize this and learn in the real space by doing that. And what I like to do is create an example if we talk about a typical lean or TPS transformation on a company that Ali and I visited, what it might look like. And then our initial ideas of how AI might overlap on that and take this culture of highly engaged people to another level. So I'm going to tell a fictitious story, but it's grounded in reality. And we know we have a lot of lean practitioners on the call here. So imagine you have a company, has about 100 people, and they are making a product that's about the size of a basketball. And this product is a casting that is machined, and they're welded components. And this product goes in the underside of trucks, so it's safety critical. If it fails in the field, you're going to have a large truck accident. So it's really safety critical. And because it has casting and welding, you have vulnerability for internal defects in the casting that you have to do destructive testing for, or welding that you have to cut. So you're making that product. And I'm going to use 20 to make this story simple. Imagine there are 20 different versions of that. So there's some changeovers. And you've got a customer that comes to you and says, hey, we need you to reduce your price by 10%. And you're making a 5% margin because we can get this product from someplace else. And so your improvement need, if you were thinking about TPS or continuous improvement, is I've got to take at least 10% out of my manufacturing cost or my overall cost so I can still make a margin. So that's your challenge. So in comes the Toyota production systems, or how do we do that? So just imagine this area makes 20 products. They have 20 machines. They have 20 people. It takes them about 20 minutes to do a changeover. They have about 2 hours between machines. The machines are 10 or 15 people apart. It's a very traditional type operation. They use a push system using MRP. They don't have a daily huddle where they talk about the status about how things are going in the plant. And they certainly don't have TPS style team leaders, which are there to have one for every 4 to 5 people to do standardized work, problem solving, training, and help with output. So that's the condition. So what would we do with that simple, with a good lean transformation that we would do over a year or so? So imagine what we would do. The future state would be that area would have 1/3 the space. These machines would all be put side by side to be continuous flow. The changeover would go from 20 minutes to less than a minute. That 2 hour of inventory that we might have between machines would be minutes. Instead of having 20 people, we would do improvement like crazy, and we'd have 12 people that are actually running the machines, and we'd redeploy 3 people to make team leaders. So we'd go from 20 people to 15, but there would be 3 people that are doing team leaders, which are problem solvers and improvers. We would establish a really good daily huddle that every day we looked at safety, which they're not looking at today. We look at quality, scrap, rework, productivity. They would look at labor productivity, capital costs, maintenance costs, overtime. They look at their delivery and their inventory, and they do a lot of work on HR and training at their daily and weekly huddles. And instead of having an MRP-based push system, we'd create a pull system. So we'd have a just-in-time system that would bring lots of problems to light. And so we do all that, we can pretty surely take at least 10% out of what I described, probably do it with fewer machines. That would be a typical TPS style or lean, as I described, transformation to get dramatic improvements in quality and cost in a short period of time. Lee and I visited a company like this, and we were talking at great length, well, how could this be enhanced with artificial intelligence? And Lee alerted me to 2 things we could do that were really fascinating to me. I'm very interested in learning. So let me give you those 2 as examples, and I'll hand it back to Lee. So one of them is the product that we're making is a casting that has internal voids and is welding that you have to check by destructive testing. To check voids for both castings and welding, you have to do destructive testing. Most companies, to try to reduce the cost and expense of destructive testing, is they monitor a process to be predictive of when there will be a problem. That's typical what best practice is. With Ali's magic that he's going to talk about, we can add a lot more sensors and data to monitor the manufacturing process at a totally different level to be vastly more predictive of when I'm going to have a weld problem or an internal void problem, to predict that, which would save a lot of cost and time on the destructive testing and have much higher confidence for the customer. So to me, that's a major breakthrough that existing methods have some limitations. The second one that I'm really excited about is TPS has this feature called Jidoka, which is you want to signal abnormalities as they occur. And if you have a machining center, like we said, there might be 20 machining centers in this operation, they have sensors on them. They monitor temperature, speeds, feeds, maybe a little bit of vibration. And so they do monitor themselves, but they're pretty limited based on what you get from the machine tool builder. What Ali said to me is that, Jamie, there's a possibility we can add more sensors to that equipment that are inexpensive. We can take the data off the existing sensors that are there. We can put them into an AI engine of some sort, and all of a sudden we can put conceptually a plasma screen on top of that piece of equipment. And now, instead of knowing only if 3 or 4 things that we're monitoring are wrong, and we only know if they're off real time, we can monitor 20 things and look at trends and data and actually say, almost like statistical process control. So you could have Jidoka on steroids. You could signal problems at a vastly higher level, which enabled you to run more reliability from quality, uptime, and cycle time. So those are 2 examples where the artificial intelligence would take a typical TPS transformation to a very different level. And that information and data in the hands of these highly engaged, passionate people that are solving problems improvement, I think they could really run with that and take us to a different level of performance. So a little long-winded, Steve, but I just want to kind of make that vivid for those of us that work in this space, how this dream of how this might work together. I'll hand it back to you.
I think that's fantastic to highlight. And, if I'm paraphrasing, it's really exciting to think about the possibility of AI to enhance our natural abilities, right? We are pattern matching beings. We are problem solvers. We get really excited when there's an opportunity to improve something, and making those problems more visible, more clear, and also highlighting when we're heading towards a problem, I think is incredibly valuable. Really addresses the frustration of being confronted with an issue and allows us to be more proactive, right? And understand more about the flow of work rather than interruptions from defects and problems that arise, in traditionally seemingly out of nowhere, right? When we know that these things there are indicators. And the question is, can we see them? Can we see broad enough? Can we see deep enough? And can we correlate effectively to find those things? So, Ali, do you have anything to add to that? Anything from your perspective that digs a little bit deeper on this, or a different aspect of this you want to highlight?
Yes, well, it has been really such a pleasure working with Jamie, and he described such a beautiful example. I always remember of Einstein's quote, make the problem as simple as possible, but not simpler. And the not simpler is these AI tools are around. So why are we not doing what Jamie just mentioned in a large scale? And the reason of it, and if you look at some of the highlight in some journals, 87% of the AI project don't come to fruition, or you didn't get ROI and so on. There is something that is missing here. AI has the power, but the challenge is AI do great work, but need training data sets. They need cases that had seen before, and each operation is different. So the reason why AI is so good in image recognition, of cars and people, is that they have millions of examples of those images, and now AI systems do that. But if you go to any operation, they have slightly different machines, slightly different ways to do things. And so as a result, you cannot just do it right away. That's number one. The second is AI need to see examples of anomalies, and example of who is going to provide that. It's not that automatically, but humans do that. Operators who work the machine, they have intuitions. about certain anomalies, and only working together, then you have the right annotated data sets to be able to deploy AI. So I think that's what I wanted to mention, is really human is important and each operation is different. And again, I'm visual, so let me quickly share a couple of slides, because what Jamie have described, we have been trying to do with a couple of our local manufacturers in the region. And hopefully you can see these slides. By the way, I know the audience is broader. We have healthcare and others. What I'm describing could apply to any small organization. And quickly, we have been doing by learning, correct? We have been working with 27 manufacturers since 2018 and doing digital transformation and slowly applying AI. And by the way, there is an article with Willy Shih at Harvard Business School that have come out 2 years ago, describe some of the lessons. We installed a lot of sensors. We tried to do some learning, and some of the lessons we have learned, and I think by example, is this challenge. It's not easy to scale. And the other thing I want to say is this is a journey, and because you need to change certain roles and know-how inside the factory, a good way to do this is groups of companies with similar problems. And so what we have this cohort model, it comes from strategic doing. Ed Morrison and others have helping us. Teams define problem, design pathways, launch project. That seems normal. Any planning is this. Something about when each operation is different is you need feedback loop. Every 30 days, these teams come together, what we saw in our operation versus another, and they come back. And after 6 to 12 months, they get to some results. Let me again even be more concrete and tell you about a discrete manufacturing cohort. What you can see here is example of a CNC machine, 3 companies, seam welding, stamping, and plasma cutting. You think all of them are different, and it's true, very different machines, very different processes, but at the end, it's discrete manufacturing as repetitive. The common challenge is that no real-time visibility at the end of the shift C reports, wait times for materials and engineering limits. That's what manufacturing is about, solving exceptions, solving problems on the manufacturing floor. And then, of course, unplanned downtime has huge impacts. What we have done, and these are the group of faculty and researchers, students, we have developed some low-cost IoT solutions, and again, tell you examples, some data pipeline for simple visualization. Then with the help of the machine operators and some algorithm on what we call part fingerprinting, we have been able to provide this type of work information that Jamie already highlighted. Let's again, exactly examples. These are sensors installed on the machine. This is like an open source dashboard, tell you which equipment you are using, which part you are making, but there is some fingerprint of that part. And that's what Jamie was alluding about quality. If you focus on the fingerprint, by just looking at the current that the machine consumes, you can actually tell you if it makes part A versus part B. And here is a superposition of parts made in a shift, and you already see 3 outliers. This shift had 3 bad parts. These are things you can now see right away before you reach the end, and real-time feedback is important. This information is what students provide, but then the business operations need to include it. This is an interface that TMF Center, one of partners, developed on their own, because the question is now this information, how it changes information flow. And a success example is a Kirby Risk. In 1 year, between November 23 to November 24, while they went through workforce attrition, it's hard to get skilled labor, they were able to increase productivity by a factor of 2 and significantly improve on customer past dues and so on. Why is, again, the time request for materials and some little things was improved significantly through real time. You say this is all technology. Where are the people? Well, this could not have worked before if you could not engage factory floor workers to tell you what are the risks. And actually, this also reassigns some of the factory responsibility. Processes need to be changed, and that's the feedback loop that is hard. I want to be mindful of the time. What is the journey of these manufacturers? Sometimes, okay, you solve a problem, what is the next step? The way we see the journey is traditional. You go from descriptive AI tool to diagnostic to predictive and then prescriptive. Descriptive, you need to have good data. The challenge is sensing is a problem. And if you get anomaly of a sensor versus anomaly of the part, you can never differentiate. AI can help with that with the right operator input. Then once you have that with part fingerprinting, we can improve scrap analysis, wear and failure. That's a diagnostic. Eventually, we want to be on the predictive quality, predictive tool where we are not there, 3 companies are here, and then prescriptive where we go. So hopefully that gives an example. I want to skip the second one in the interest of time. We do the same thing with continuous manufacturing. In this case, is a wire manufacturer. We combine quality maintenance as well as process data. Here is another example Jenny mentioned. Human cannot digest all of this. Even when I plot it, I only have to plot a down select. Here we are using some predictive model. These are some of the AI tools, lots of input parameters, lots of output, but the root cause analysis AI. But again, we need process knowledge and the people do it. The last example I want to give is an example of imaging. This is a process that is 12 days, is a food processor, and a person was looking at the images and is like cooking, tell you it cooks well, let's continue. But it's a 12-day process. We developed a privacy-preserving image analysis, and now is used on a daily basis in the whole factory. How it works is that manufacturers get an analytics of an image, and that's actually interesting. This is a collaboration work we are doing with Harvard and My Data Can. They do the analytics and all of this without us seeing their data, or they see our algorithm, double side blind, and now we are doing agglomeration, and all of these thanks to this type of privacy preserving platform. And maybe that's my last point. AI benefit with lots of data. Nobody will give all of their data to somebody else. We need this collaborative platform where you learn from each other, but benefit stays with you. And Latanya Sweeney has been thinking about this quite a bit. This is something we call AI data communities. How small, medium manufacturers and their workers could take ownership of their data. And the idea is you need to control on the data and the governance. You just give it all of your data to Amazons or Googles. Of course, they take the maximum benefit. We think a co-op possibility with the right privacy preservation can provide a large training data set benchmarks, and that's some of the areas that universities could work. I think that's all I had. Let me quick summary. Manufacturing small medium is so important for resiliency. About 91% of these factories have less than 100 employees. So this, how we bring AI on a smaller players, that's critically important. And I think another point to mention, technology alone is not enough. And hopefully today discussion with Jamie highlighted the importance of the worker engagement and more higher level, how do you change job functions?
Beautiful, beautiful. Thank you, Ali. That was great. I just want to highlight a couple things that stood out to me. And you mentioned them a couple times, but I just want to kind of emphasize that, you're talking about low cost sensors. I think that's very important, right? The low barrier to entry is one thing, but it's also the ability to, experiment very rapidly and scale up multiple efforts in multiple parallel approaches to see what performs the best, right? And test many different assumptions. And I think that's very important. The other thing is the importance of open source, especially when you're talking about community. But I think that, what I've seen with a lot of organizations is that you get the best results when you tailor solutions to the environment, when you tailor the solutions to the needs of the customer, the organization, the business, the cohorts that you're serving. And that looks very different depending on context, where you are in your journey, what the culture of your organization looks like, how people want to consume information as customers and users. I think that's so critical. And then the other thing that I think is really important, and it touches on what you've mentioned, Jamie, the human importance of this is that, we know that the best solutions come from the folks doing the work and the folks who are on the line, actually in the flow. And it's so critical for those folks to really understand deeply the problem solving process, what a problem looks like, how to define it, how to capture it and communicate it, and how to really drill into those problems, because that can be enhanced by AI. But I think that attitude, behavior, mindset, the models and the ways of thinking that kind of spark the insights and that pattern matching that's so critical, and even the ability to collaborate effectively with different people with different perspectives is absolutely critical to this. So I just want to call that out for the audience. I think it's super important. Jamie, anything that you want to highlight
Yeah.
from Ali's presentation or
Yeah,
your
you can
experience?
tell I'm very inspired by what Ali has shared, and we're really looking forward to work together to bring these ideas jointly together. So I did make two comments. One is that to build on your point, Steve, when we work with organizations to build a lean transformation or TPS transformation, often one of the biggest challenges is building problem-solving skills and capability. If you do a transformation like I just described in our example of the castings, and you have tightly connected machines with tight changeover and a pull system and a high level just-in-time and Jidoka, what's going to happen is lots of problems are going to come to surface intentionally. And you have to design an organizational structure, team leader-based structure, and engage and develop and teach people to solve problems so they don't reoccur in a manner that those people are fulfilled and engaged by that and want to keep taking on more problems. And beneath that is a skill of how to solve problems, which conceptually is very simple using scientific thinking, but in practice takes practice and skill and coaching to build that problem solving capability. So that is really important. The second point, what Ali mentioned a little bit, but I want to amplify it. What I'm personally very excited about what Purdue is doing is they're trying to bring these methods to these small to mid-sized manufacturers that often don't have big IT departments. They don't have people on staff that are gurus in information technology. They're trying to bring this to these companies in a practical, low-cost manner by collaborating with companies to help them learn together and improve. So I think it's a very exciting frontier to make this more accessible, which is why I'm hopeful Ali and I can find some projects to work together, and maybe in a year we can talk about some of those examples of merging these ideas together.
I would love to be here for that conversation. So, picking up off that note, Jamie, where do you see this going? So, where does this progress in the future? Let's say that some opportunities emerge with some companies that are looking for this type of collaboration. Where does this go? How's it developing, and how do you see that type of engagement actually coming to fruition?
Well, two things. One, for the purpose of today's conversation, I'm hoping that TSSC and Purdue will be able to work together on some companies that's in their sphere, North American companies. Hopefully we can find some that are already on a good continuous improvement journey and working on that capability, and then we can do this stuff together and learn together and add that to the cohort group that Ali talked about. So that's what he and I are hoping to do together, and we may join forces with some of the other nonprofits that Kelly mentioned in the intro to do some collaborative work and experimenting together to move down this frontier. Our understanding, and we could be wrong, or certainly my understanding, is this is a new frontier. There hasn't been a lot of work yet deeply thinking about how do we integrate lean and continuous improvement with artificial intelligence. There's sort of a new frontier with what AI can do, as Ali mentioned, and so we'd like to do some trial projects on that frontier. But there may be some other groups that are talking about this integration that we're not aware of, and I hope to hear about some of those and figure this out. So a few years down the road, we'll have some case studies, we'll have some lessons learned about how to do this effectively. What are the limitations? What are the unique challenges? What are some practical guidance? So this can be 3 to 5 years down the road, more accessible, practical to a broader group. And there are big challenges, like Ali mentioned, about data integrity and data accuracy and privacy. You know, there's things to work through, but we'll do that for trial and experimentation, and learning together would be my hope.
Excellent. So I want to get to questions from the audience. We have some great questions coming in. I want to encourage everybody to toss in your questions if we've sparked any thoughts or curiosity. But before we go to audience questions, I just want to kind of cap off this section of material. And I'll ask you, Ali, first, what's maybe the most important message or two that you would share with folks who are trying to approach these types of efforts?
Um, Probably the most important approach is that often AI is considered as, replacing jobs and, what happened. I actually tend to think otherwise, meaning that before this AI revolution, we had digital transformation, but people who had computer science background, who could do programming, the IT department was one type of education, and people on the factory floor and the one who know operations and run was a different type, and you didn't want kind of both, and it was very hard. And part of a challenge in today's organization is always clashes between what the IT permits and what the people on the floor want to do. AI enables people on the floor to access data and manipulate data in a way that they could not do before. And if they could collaborate, they can together do more things. So that's question number one. The second is what Jamie mentioned is essential. Big companies have an AI department, correct? They hire PhDs, then they go and they look. Small organization, they don't have those resources. And so as a result, the gap between big and small gets bigger. And that's part of a challenge of this, a lot of the gaps in the country increasing. Why 250 years after Industrial Revolution, we have 98% of US manufacturers small and medium, correct? If everything was economy of scale, well, then everything should be 5 companies and everybody happy. No, small mediums have the agility to do things, and they can provide. These are the ecosystem for the big ones. If we lose the small ones, the big ones cannot be as competitive. So we have to find ways for the small ones to get access to AI, and through some sort of community co-ops and this type of thing is important. That's number one. The second, you learn by doing. Is how many webinars you attend is great, but the next part of it is how to do it. You need to have a discipline, and I think that's hopefully people will be interested to start working on it.
That's such a great point. And it's a topic that keeps coming up, this idea about leveraging AI to cut costs. I mean, lean suffers from this as well, this kind of association with minimizing, right? And I think that, what kind of comes to mind for me is this difference between a scarcity mindset and an abundance mindset, right? I mean, a lot of folks will naturally think about minimizing, cutting, reducing, partially because complexity is hard, scale is hard. You increase surface area, things get potentially more difficult, especially if you don't have a solid foundation or model to work from. And but there's such an opportunity for abundance here, right? Such an opportunity to do more without working harder, to expand your horizons, to go deeper, to go broader, to chase new opportunities, to test new experimentation and innovation. So I think that we should all take a step back when we're thinking about AI and wonder, are we approaching a problem from a scarcity mindset or an abundance mindset? And are we thinking about the possible, or are we thinking about, maybe stepping back to be more cautious when we could be leaning in? Jamie, what about you? What would you share as kind of the most important message or two about approaching these types of efforts and investments?
I'm going to echo what Ali talked about at the beginning. Jamie's personal perspective is over the last 50 or 100 years, there have been waves and waves of new technology. He described a whole bunch related to information technology, and we've seen this continual evolution on a whole bunch of front. And I see what's happening with artificial intelligence is along that continuum. And like the other technological breakthroughs, there are important benefits and cautionary things about how to implement. And I think we'll be on that journey here. There's a lot of energy about artificial intelligence now in the news, in the media, and different applications, and we will need to experiment our way through. And at the end of the day, my personal opinion from working in the continuous improvement field is it all boils down to people. People have to review data, input data, solve problems, and make improvement. And if we can harness the power that the new computer technology has to better engage people and help people solve problems and drive improvement in a way that they are more fulfilled and we have better performing operations, I think that will be a win for everyone. And that will be our challenge. And then the only other thing I would say, Steve, today's podcast, we've anchored our conversation around a very practical sort of manufacturing example that's relatable to this community. There's certainly a lot of other fascinating applications of the interface of continuous improvement and AI that we could talk about administrative areas. We could talk about administrative processes. You know, we said that TPS and continuous improvement and lean applies everywhere. It's easy to see on the shop floor, but it applies certainly in product development. And so there are different types of interesting application in those spaces that maybe we could cover at another session.
Yeah, this is an area I'm super, super passionate about. Coming from the software world and the technology world, the application of lean to knowledge work, I think is a critical area for us to hopefully dive deeper into in a future session. But, I hoped that this is a start of a long conversation about many different areas and opportunities and industries and aspects of work to be done and where we can have all of these approaches and technologies and techniques come together. And so we've got a bunch of questions. We've got some questions that have been upvoted. So I'm going to start there. Again, thank you to the audience for throwing us questions. That really, I think, keeps this as relevant as possible to you folks. So thank you for that. I'm going to start with a question from Charles. And I'll go to Ali for this first. Ali, what do you see as the roadmap for large manufacturing IT teams to drive meaningful effectiveness gains through AI? And I'll pause after that and maybe we'll touch on the second part of the question because there's actually two.
Well, I guess that question requires some precision what they mean by this large manufacturing IT teams, which part of it. The way I look at it is there is an IT platform that is needed to enable data gathering real time, to make it easy for operators to say, and that's a big role they have. But the interpretation of the data and the annotation and so on, then the operation need to be closely working with them. That's where you need this type of worker engagement. But the question is, how do you do it systematically? And I think that's a process that people are learning by doing. One of the biggest questions that we hear from our manufacturers every time we want to do a project, this is what IT team allows us to do, this is what doesn't, because of course they have to worry about all of the hacking and all of the other things that usually IT worries. But I think on the decision making and so on, there's a lot that can be decentralized, and it's so specific that can only be done on the floor.
Excellent. Well, let me maybe go to Jamie for the second part of this question, and then we can jump back and forth. Jamie, what do you think folks can expect a well-prepared team to achieve over a time horizon of a year, 2 years, 3 years with this type of effort?
So the example that I described up front, the quasi-fictitious example about dramatic improvements, that is very achievable in a year or less with a highly committed folks. If the intention is to build a lean environment, which I said up front, is everyone learning how to create and flow value easier, better, faster, cheaper for everyone's benefit. If that's your focus, the kind of transformation that I mentioned is very doable in a year's time, and a lot can be done. How long it would take to turbocharge that with some of the concepts Ali mentioned, which I'm very excited about. We're hoping to work together to see how fast that could happen if we try to do those together. Do we do them in parallel? Do we do them in sequence? But I do want to emphasize something. See, what I described about this lean transformation that's very possible is not mainstream in North American industry. I visit lots of companies every year. Most companies are not on a rigorous, serious lean journey in North America that we get to visit. So just be clear that while some may think, well, everybody's doing some form of lean and continuous improvement, it is true that many organizations have a continuous improvement group or an operational excellence group in companies or in hospitals and all that. But few are doing what I described here, which is building a culture of highly engaged people that are solving problems and innovating to drive performance at the levels I talked about. So I believe there's a lot to be done in that space. The companies that Ali is working with, I think a number of those, if we can combine these, we can take them to a very different level of performance, and we're hoping to do that. So those of us that are working in this .org group that Kelly mentioned, we're hoping to reinvigorate an understanding of lean in the broader business community and re-engage folks in being interested in that, because there's some misconceptions that everybody's doing this, and there are also some misconceptions that lean doesn't help address contemporary challenges. And it is a powerful tool to address challenges like supply chain stability, reshoring, employee engagement and turnover and attrition, competing on speed, order to delivery, how to radically redesign product development so you can engineer, design, and develop a new product very rapidly. There's a lot more that can be done, a lot more potential in that space. And you can sense my enthusiasm. Today, compared to 20 years ago, the lean community has a lot more skills and practice about how to help organizations do that. So I know Ohio State has a terrific program in their MBOE program that's helping folks with that, and others do as well. So that's my challenge and optimism for the future.
Excellent. I'll piggyback off that and ask you a question, Ali. Our next question is about how can AI help in the problem-solving process and developing a problem-solving capability in an organization? So two parts to that, but you can take that however you like.
That's an excellent question, and that also comes from the fact that these days you can do amazing things by just chat GPT. You have a problem and you will find something similar. So I think this availability of these type of tools will simplify certain problem solvings that require digging into manuals, finding something you did before, and things like that. AI will do that. You don't need it's good to lower the burden of the people. But there is always new things. Jamie mentioned new product development. If you want to do something new, by definition, there is no data about this.
Mm-hmm.
And so we should differentiate between tacit knowledge that you learn by doing and then you develop for new things versus explicit knowledge that is written in manuals and can be discussed. All of us know certain jobs, you can learn them in 1 or 2 days. Certain other jobs take you years to get good. Why years? It's not that over the years they get better manuals. No, because you need to learn by doing. AI cannot currently penetrate tacit knowledge. Why? Because it's not written by definition. What can you do with it? So I think this problem solving need 2 elements: the simplified explicit knowledge using the chat GPT and so on, but you still need the mentorship and all the old fashions that people did for the tacit knowledge. But there is a path to get from the tacit to explicit. That's the area of research. That's actually one of the areas we are working on.
That's
May I add
fantastic.
something to that one?
Sure, absolutely. I was going to throw to you for the TPS lean perspective.
We had a conference that Kelly was at that actually inspired this webinar at OC Tanner with the Future of People Work Initiative with all the NPOs that are collaborating in June. And there's some folks that are trying to tackle a problem that we have in the lean community, which is to learn the problem solving that we talked about is very important for more intricate problems. It typically requires a very good coach. And that coach has a lot of tacit knowledge and skills. I've been the beneficiary of being coached by some terrific Toyota people that coach people on problem solving. And it's a very kind of like an apprenticeship model where you work on solving a problem, you get coached by an individual. I'm sure there are a lot of professors at Ohio State that do this in their field of discipline, that they're really great, and at Purdue. So there's some folks that are working on it. So, well, there've been a lot of books written about problem solving that have taken a lot of TPS type problems. So I've taken a lot of tacit knowledge and make it explicit. They're experimenting with taking what's in those books, putting it in one of these language models, and figure out, could you create an AI-based coaching tool that could provide good or basic coaching to people. So if I was trying to solve a problem on my own and I'm at 11 p.m. at night, I can talk to an AI problem-solving assist device that may not be as good as a master problem solver, but may be good or good plus. And if we could, there's some folks that are thinking about that. And I think that may be what Ali is alluding to. Maybe down the road, we could do that. Also, something like that, maybe we didn't talk about it today, but I'm very intrigued with that. Tacit knowledge also exists in amazing maintenance people and engineers. You have a piece of equipment that goes down and say, we got to wait until Sue comes in because Sue knows how to fix it. And Sue walks in and fixes it real quick. Well, she's got a lot of tacit knowledge and experience. So maybe we'll may have one day where we can effectively capture a lot of that tacit knowledge and make it available for people at a very low cost so that we have more accessible coaching and development. But these are dreams for the future. They're not reality yet, but exciting for some of us to work in those frontiers.
Definitely, yeah. There's a piece of that abundance mindset present there for me that, what we're talking about is a yes and, right? An additive, like in addition to your coach that's available for a very limited amount of time where you get deep expertise and an incredible ability to maybe drill down into something very fundamental or insightful, that accessibility for when you're just about to fall asleep and you think about that thing like, oh, what should I do in this scenario, or what should I really think about going into that meeting tomorrow? Having that available, I think, is very powerful. I think the other thing that I wanted to highlight there was that this piece about AI and problem solving is we have a couple of challenges that the technology hasn't addressed yet. One being that a great coach will challenge you, right? And AI really is not great at that today, right? It's really not great at pushing back and saying, well, are you sure about that? What if you change your perspective slightly? Have you thought about this? Can you tell me more about that to test, do you really understand this thing, or have you just kind of picked up a word or a phrase or something? That I think is very important. And then speaking from my experience personally, I learn by failing better than any other way, right? So if I want to learn problem solving, if I want to learn anything about improvement for me, I really have to try it. Um, I really have to kind of cement it in my mind by establishing what doesn't work, or where I was off, where I needed to be corrected. And so AI can certainly help me fail faster and fail across multiple different iterations much more efficiently perhaps, but I still think that there's so much time to be saved and so much value in having the yes and, the yes and model of abundance, saying we have experts, but they're augmented, they're supported, they're enhanced, they're made more accessible,
Yeah.
and they're able to
Yeah.
maybe tackle a broader
Right.
area,
Right.
whatever that may be.
And Steve, we've experienced that in our lifetime. When I went to college, I had to type papers on a typewriter. We now have word processors. We now have spell checkers. We now have things that are a job aid, but not a job replacement. So I know that's a simplistic example, but I can see a world where this could be the and.
And Steve, maybe I also want to follow up on your comment. The greatest skill of a coach is to understand that each person is different, and you adapt based on how they are. And it's very hard for AI to do that. So I think what you need still a coach who say this part of the AI, take it into account, this don't, and so on. For these, you need to fail first. Don't always ask AI. So a coach is needed to, but it only works if it's in tandem. You cannot replace the coach with the AI.
Definitely, definitely. Okay, so maybe one of our last questions that we'll get to, and we'll see, maybe we squeeze another one in, but I think this one is going to be really relevant. It's very relevant to me because we see people get captured by the latest thing, right? The trend, the shiny object. So how do you keep people from being captured by sort of the novelty of a new technology, a new technique, a new ability? And this tendency, I think, when you have this new shiny object, to either dive in prematurely or wait until they feel like they have the perfect data, the right case to tackle, the right team, the right timing, all of these things to be perfect. So on either end of the spectrum, if you're diving in too quickly or taking forever to initiate some effort like this. Jamie, I see you nodding. I'll go to you first. Any thoughts on that? Oh, I've got you muted right now.
I'll make a comment on
There we
that. I
go.
hope I'll have a chance to make a very brief closing. So strong suggestion, and it's been a theme, is trial and experimentation. Start with a small project, get some experience, and you'll be much wiser to figure out where to go. And small trials and experimentation, you can learn quickly a lot, which is exactly what I'm hoping Ali and I and some others can do on Work Together, to do some experimentation about what, and then you're much wiser in the future. That's the approach I think is a really powerful for learning. So I just make that comment, and what is embedded in Ali's whole model and what he's trying to do with these SMEs.
And maybe quickly, I want to add that there is this theory of diffusion that you want to wait, early adopters to try and so on. The challenge with AI is a rapidly evolving field. If you don't try early, this is hard to catch up. Businesses will change. So you need to start what Jamie suggested early, and you need to be committed. It's not that, okay, side project. But of course, you need small but deep.
Hmm. And I wonder about maybe maybe I'll selfishly kind of piggyback on that with a follow-up question. One thing that we saw with digital that I think proved to be detrimental is this idea that digital was another department or silo of the business, right? A separate entity where maybe all the innovation was happening, all the experimentation was happening. And, we've slowly kind of migrated that to a layer of the organization, right? Just everywhere enabled by technology with digital capabilities. Do you see a similar trajectory to AI? Are those things true for AI? Is AI fundamentally different? Um, Ali, I'll go to you first, and then Jamie.
AI is a different way of thinking, so you need people who are deep in that, but they need to be embedded and work and understand the problems. They cannot be separated. It's not just like separate the data and others just handle it. So closer interaction is needed, but not everybody can become AI expert, and that deep understanding takes time.
Jamie, any thoughts on that
I
and
can't
where you
I
see it
can't
going?
add to that. I can't add to that. I don't have my experiential learning yet on the AI frontier to have anything meaningful.
Well, I think that's maybe for the best. We are probably out of time. I see Kelly show up. Thank you, Kelly, for jumping in.
Oh
And
my gosh. Yeah. Thank you guys so much. This has been, yeah. Thank you, Ollie and Jamie, for your expertise, and Steve for your amazing emceeing skills. It was such a thought-provoking discussion on that intersection between AI and lean, and we really, really appreciate you being here today. So before we end the session, I just have a few, two quick comments for the audience. On behalf of the Future People at Work organizations, we'd love to have you join us as we continue this conversation. We're going to be doing sessions, we think, every 2 months. So part 2 will be likely in mid-October, so look out for that. Second, we're going to send you an email after this. It'll include a survey link about your experience today. We'd love for you to take a quick minute to answer those 4 questions. It'll include the contact info for Professor Shakouri and Jamie and their organizations if you or your company would like to engage with their work, and information on how to access the video for this session if you want to rewatch it or forward it to others who want this to be highly accessible for the broader OpEx community. So thank you again, gentlemen, and thank you all for joining us, and have a great afternoon.
Thanks, everybody.
Thanks, everyone.